Millen, you can start.
Hey, good morning, good evening, good afternoon, everyone. Thanks for joining us here today. We have an exciting topic that we're really happy to be able to share with you, just to share sort of what IBM is doing and where the industry is going related to FIDO, Passkeys, and passwordless. Today, actually, I'm joined by one of our resident experts and also SMEs in the space related to passwordless and FIDO. Shane, I'll let Shane introduce himself.
Hey folks, my name's Shane, and for those who haven't met me before, I've worked in IBM for more than 20 years now in identity and access management through federation and into strong authentication, and now WebAuthN and FIDO. I work in our architecture team, delivering solutions and products to our customers, as well as participating in standards bodies like the FIDO Alliance and the W3C WebAuthN working group.
Thanks, Shane. And my name's Millen Patel, based in Raleigh, North Carolina. I'm on the product management team for IBM Security Verify, work closely with Shane. And today's webinar is going to be pretty straightforward in terms of what we're going to be covering. We're going to be covering first, what is IBM Security Verify? We're then going to get into some of the trends that are happening with Passkeys and FIDO, and Shane's going to be covering that. And then he's also going to cover some of the best practices, some of the considerations that organizations for employees and even consumers need to think about as they're looking to roll out some of these experiences and what the implications may be. So with that, let's go ahead and get started. But before we get into the meat that Shane's going to be covering, let's briefly talk about what is IBM Security Verify, right? And if you were to ask any of us here at IBM, what is our mission related to Verify and identity access management? It's pretty simple. Our mission is to help securely connect any identity to any resource. Now, as we peel that down, we realize that there's different use cases. There's workforce identity, right? Employees accessing employee systems, and given the shift to a hybrid workforce and considerations of how individuals are accessing resources, applications, operating systems, networking utilities outside of the typical boundaries, we're really focusing on how we enable that without necessarily compromising the security, but also enhancing some of the user experiences and the interactions that those workforce employees have with those resources. And of course, the second one is around consumer, right? So this is individuals interacting with their favorite brand, how they interact with them, and how they continue to sustain that relationship, and ensuring that all interactions are secure and all interactions maintain a frictionless type of model. When you boil down IBM Security Verify into its core essence, it's continuous access and governance, a unified platform that provides single sign-on, multi-factor, risk-based authentication, passwordless, FIDO, passkeys that we're going to be covering specifically for this topic, as well as the lifecycle of identities. We're talking about provisioning, deprovisioning, joiner, mover, leaver type of scenarios, as well as embedded data privacy and consent management. Now, we realize no one starts brand new. Everyone has complexities in terms of existing applications, existing user repositories, existing applications that may be starting to move to cloud, that are already in cloud, or remain on-prem. And this is where ensuring that that Verify provides the pendulum to be able to protect resources on-prem as you move to cloud, and even in some cases where business requirements require you to keep applications on-prem. This is sort of our mission. This is our mission, and this is what we're after as it relates to ensuring that identities are protected and organizations can continue to securely interact with individuals, resources, and things. Now, when we break this down, the IBM Security Verify portfolio is providing the ability for organizations to meet various business requirements. Now, our offering in the cloud is called IBM Security Verify SaaS. And as you can see with the matrix here, this considers workforce, consumer, and identity and access, our identity governance administration use cases. When you then think about business requirements where data residency, on-prem requirements, airtight gap scenarios are needed, This is where IBM Security Verify Access, our on-prem access management solution, helps, and IBM Security Verify Governance, our on-prem identity governance administration solution, helps. And as you can see, the breadth of the portfolio really is to provide organizations, partners, a choice in which model meets business needs, still providing the core functional capabilities around single sign-on, multi-factor, risk-based authentication, and governance and lifecycle management. Specifically for our IBM Security Verify SaaS portfolio, this is the breadth of the capabilities as we think about it across single sign-on, multi-factor, risk-based authentication. From a single sign-on, risk-based, multi-factor, and risk-based authentication standpoint, we provide registration and profile management, a directory out of the box, passwordless, social login, as well as custom branding. And specifically for passwordless, again, Shane's going to be covering that. From an identity management and governance, out of the box capabilities for profile management, delegated administration, data privacy consent, provisioning and deprovisioning of access requests, and synchronization of users across from targets and verify, and being able to do remediation policies, as well as being able to do access recertification campaigns for auditing. I'll talk about the platform and compliance here in the next slide. And from an administration standpoint, we provide out-of-the-box reports, out-of-the-box integrations using standards protocols, using webhooks, for example, and then being able to identify fraudulent users using a risk-based engine that looks at the user's interactions continuously as they're interacting with resources, both web and mobile. As you can see, this is a comprehensive suite, comprehensive solution, all delivered from the cloud. Now, when we talk about delivered from the cloud, IBM Security Verify, the SaaS platform, is delivered in 6 regions. We have US, Europe, China, Japan, Canada, and most recently, we're deployed in Australia. We also have a list of certifications given the industry focus and investment that we're putting on how enterprises and organizations can take advantage of Verify, not only to meet the core security use cases, but also comply to industry-specific verticals. Here you can see how we're aligned to PCI SOC 2 as well as ISO, and as of August 2022, HIPAA ready, and then also considering how we're investing in the public sector. There's also an industry focus with what we're saying and what we're calling high assurance identity in the notion of open banking and financial grade APIs. Here you can see how Verify is supporting things like MTLS, private key, push authorization request, and complying to industry and geo-specific certifications for how more modern and secure implementations of OpenID Connect are realized. And you can see the investment that we're putting forward as we continue to look at delivering CIBA and other financial grade API related items in the context of delivering that within IBM Security Verify SaaS, but also IBM Security Verify Access, our on-prem solution. So with that, focusing on passwordless and IBM Security Verify, today IBM Security Verify supports WebAuthN as both platform authenticators and FIDO security keys. Another method, again, not necessarily a topic for today, but another method for passwordless supported is QR code via the IBM Security Verify Authenticator app. And one of the things that we'd like to share with you is Shane and I, every single day when we log in, we go through the IBM Security Verify SaaS platform, and passwordless authentication, multi-factor authentication is rolled out for all IBM employees. You can see on the left the login screen that I personally see every single day. And to the extent where when it's time to reset and change my password, I've got to think about what it is because I'm so used to the touch key and the security key associated with logging in from my MacBook using FIDO. This is something Shane's going to be demoing, but this is a reality in how a large enterprise, 300,000 employees, are looking at this and using this every single day to streamline how we become more productive, how we become more phishing resistant, and how we ensure we're able to access resources at any given time and actually doing so in a very secure, trusted manner. So with that, I'm actually going to hand it over to Shane to talk about sort of where the market's going, specifically with Passkeys and FIDO.
Thanks, Millen. And let me just get things started here. Okay, so I want to talk a little bit about the scope of today's discussion. It's not really like an introduction to FIDO and WebAuthN, and FIDO's been around for quite some time now, and I suspect many folks on this call have already heard of it or may have even used it. But it's seen a big surge in interest, and we're getting a lot more inquiries about it. Mostly, I think, as a result of some key announcements and deliveries that have occurred over the past 8 or 9 months. And that's what I really want to talk about today, is what these announcements were, what's been delivered, what's being delivered, and provide you a bit of a perspective on my point of view and IBM's point of view about some of these new capabilities and what our advice to our customers might be. So this all started back in May, these recent announcements, when Google, Apple, and Microsoft got together, and through their collaboration in the FIDO Alliance, put out a press release saying we're going to support Passkeys on our platforms to accelerate the adoption of phishing-resistant authentication, particularly in the consumer space. And Apple have actually been the first to market with this concept of a passkey. They announced it a couple of years ago, their intent to deliver WebAuthN and in Safari, and then over the last 12 months or so have delivered via beta and now in general availability in iOS 16 and macOS Ventura support for passkeys. That was done at their Worldwide Developer Conference earlier this year. And similarly, Google announced at their Worldwide Developer Conference, Google I/O, around the same time, this was mid-year, that they were going to release passkey implementation on Android, and that is in beta right now. So, and Microsoft's announcements have been an intent to deliver it next year, and they're making progress towards that. So that was the joint announcement that sort of really kicked off a lot more interest in FIDO, and the main reasons it's doing that, I'm going to explore the reasons why that interest exists now. So what I did is I went to the FIDO Alliance website and pulled down their Passkeys page and grabbed a few pieces of it to sort of seed this discussion. And the definition I found on the FIDO Alliance website for Passkeys is somewhat all-encompassing. It's simple, easy to understand. It basically just says that a passkey is a better way to log in than a password, which is very, very true. And it doesn't really make any claims about whether or not a passkey only applies to these, platform things that Microsoft, Google, and Apple have announced, or whether it also encompasses existing authenticators such as those provided by the hardware security key vendors. It leaves that it's much more high level than that. And that's why I call it a marketing definition. What I wanted to do was explore, the next level of detail of what people describe passkeys as, and arrive at a slightly more constrained definition for the purposes of today's discussion. So I scrolled down on that same page a little bit, and I found this section that says, here's what this means for user experience, security, and scalability. And I've sort of peeled the onion a little bit on some of these statements. So these are some implications that I sort of have drawn as a result of reading these sections and understanding what they mean. So let's start with the user experience. The user experience is designed to be a simple verification of your fingerprint or face, or inputting a device PIN or unlock code. So that type of experience is one that we see today on laptops and mobiles, and to me it intimates that this is a platform human to device authentication or user verification method. Similarly, there are statements in here that imply the credential is backed up and recoverable. Say, if you read into the fact that you can offer passkeys without needing passwords as an alternative sign-in or recovery method, one might imply, well, the only way I could logically do that is if my credential is backed up and can be recovered. And similarly, if I can access my passkeys without having to, if I lose my device and I replace it with a new device and I can still access my passkeys, it implies they're also backed up and recoverable. And finally here, if my credential can be created on one device that I own and then immediately made available for use on the other devices that I own, it's definitely synced across my devices. And so from these types of statements, which are used to describe the passkeys and their experiences, I've derived that for most of us who are practitioners in this space, where the market is right now, a current practical definition is to consider passkeys under the definition of them being a multi-device provided by the platform and backed up by the platform credential, similar to how password managers in your browsers work today. Now, I've got a little asterisk there because whilst I've said here for practical purposes at the moment, they're platform provided credentials, there is some intention and a couple of statements made by two of the three major vendors that pluggable passkey providers may appear on their platforms in the future, and that's quite similar in nature to the way pluggable password managers can appear in browsers and so on today, and interactions with them. So without having to have like a custom browser plugin. So that might happen down the track a bit, but at the moment, and for the purposes of today's discussion, I'm considering passkeys as those multi-device credentials essentially being provided by the operating system and browser vendors. So what does that mean from a security considerations point of view? Now, I've got a diagram here on the right, and this diagram is reused from a presentation that was given at RSA early this year, and I thank the folks at Microsoft and Google for their assistance with it. I had this logo on an earlier slide. The logo of a little human with a key is the logo that the FIDO Alliance and the vendors are using to depict a passkey. So there's some iconography as well as the use of a common noun like passkey that goes along with it to try to encourage some visual and simple recognition in the same way that we have visual and simple recognition with logging in with a username and password today. But what it means is that if I have a credential, maybe on my phone, and it's backed up to my cloud, it's synced across my other devices. And that includes new devices that I might associate with my cloud-backed account. So what are these credentials? What are the characteristics of them that make them good or bad, or just characteristics that you want to consider? The first thing I want to state right up front is, just like FIDO on a hardware security key, credentials that are provided by the platforms have exactly the same phishing resistant and other protections that are necessary to provide a better and stronger and more secure authentication experience than passwords we have today. So regardless of any other properties of the fact that they're backed up to a cloud or synced across my devices, they are streets ahead of logging in with a password, because they are still origin bound to a particular website. They can't be reused across websites. A website compromise does not release credentials that an attacker could exploit at another website. But as a result of them being backed up to a platform's cloud, it does mean that ultimately that platform and their cloud and the ability to log into that account and establish a new device as a user of that platform provider has now become the delegated custodian of one or more passkeys for that user's account. So you have definitely delegated account recovery to the cloud provider. And that might be something you're already doing today, whether you know it or not anyway. And I'll talk about that a little bit more in a moment. The other thing that has particularly come to light, and I'll mention it straight up, particularly with Apple's passkey implementation, is that you can share these credentials between different users. So with Apple Passkeys, provided you've met some preconditions that exist, such as the user who's sending a credential and the user who's receiving it have to be in each other's contact list, for example, you can airdrop a passkey from one user to another. So a passkey is not necessarily bound to an individual human. It's bound to an account at the relying party or website where you're trying to log in. So I give this first point big green tick, right? Having those exact same properties of being phishing resistant authentication credential that's impervious to credential stuffing attacks, that there's nothing but good things to say about that, and that puts it streets ahead of any other form of phishable authentication flows today. And as for these other considerations that I've put here, I've colored them yellow, not because I think they're bad, but because I think that you just need to consider about what the implications of that are in the context of your own deployment and the requirements that you might have based on what sort of business you are, whether it's an enterprise or a consumer use case, whether you might have regulatory considerations. So they're things that if you're only ever thinking about FIDO credentials as being bound to an individual hardware device, might have slightly different implications if suddenly now that the ability to exercise that credential is being delegated out to a third-party platform provider. But it might be the case that you're doing that today already with your password plus multi-factor mechanism. And I'm going to give an example of that in just a moment. So here's my point of view on what I think about passkey adoptions. First and foremost, all of my recommendations here are going to be that you should consider adoption of passkeys. And particularly if you're in the consumer space and you've got a website that only supports authentication with a password today, there shouldn't even be any questions asked about whether or not a direction towards passkeys is beneficial to you. It absolutely is. You may want to introduce passkey support in a staged manner and perhaps only on certain operating systems and browsers that support the passkey experience you want to deliver, because it is still emerging, rapidly changing and evolving technology. And so I do caution about just modifying a website and saying, look, we support passkeys, and then you getting a whole heap of help desk calls because someone's using a version of a browser and operating system that doesn't have support for it, and they ask all those sorts of questions that make your support life difficult. So I definitely advise conditionally introducing passkeys at the moment, but where you can detect that the local operating system and browser supports them, you should definitely consider exposing them for registration and authentication on your websites. Now, what about if you've got an authentication flow that perhaps consists of a password plus conditional multi-factor today? So you might be doing something like, okay, I log in with a password, and then I do some sort of, have I seen this device before detection via a risk engine, or other forms of client-side browser fingerprinting. And if there's anything that's out of the ordinary, like it might be that this user's logging in at an unusual time, it might be a behavioral pattern, whatever it is, I'm going to prompt them for additional multi-factor today, right? there's lots and lots of sites that do that. They use conditional multi-factor rather than multi-factor every single time you log in, simply to reduce the friction of the authentication experience. But what if you've got one of these sites that does this, and you're thinking about, what does passkey adoption mean for you today? So this is a couple of statements that I've been talking to other folks in the industry about, and this is a point of view I've arrived at on this particular topic. So first is, think about the threat model. Why did you introduce conditional multi-factor into your login experience in the first place? And definitely one of the reasons will have been to mitigate the threats associated with stolen and reused passwords and the credential stuffing threat associated with that, and also to a lesser extent to deal with man-in-the-middle password phishing attacks. I say to a lesser extent because a lot of conditional multi-factor experiences are still completely phishable, but the attacks for them can sometimes be a little bit harder for a malicious actor than ones where you've only authenticated with a password. So if your threat model is such that, we introduced conditional multi-factor because we were just trying to deal with the threats associated with credential stuffing and password phishing, then I would say just go for passkey authentication as a complete replacement for that. And that would be more than a massive improvement in what you've already got, for platforms where you can detect that passkeys are supported. But there are going to be some folks who stop and think about this a bit further and say, well, look, I have some concerns about the idea that a passkey can be airdropped to another user, or that it's backed up by my operating system platform provider, and I need an additional level of identity assurance beyond just the fact that it was associated with someone's Google account, I'll say, for purposes of example. And in that situation, you might want to use your passkey as one method of authentication and still apply conditional multi-factor on top of that, or in addition to that. And I caution doing that because it's not a given that that's actually going to provide you with necessarily stronger end-to-end account security. And I'll just use an example of something that you might think provides really strong end-to-end account security today with conditional multi-factor that doesn't necessarily do that. So let's imagine today that you use a authentication flow that has a password followed by a conditional multi-factor using time-based or one-time password, or TOTP, which people often have in an authenticator app like the Google Authenticator app or Microsoft's Authenticator app or our own IBM Verify mobile app. The seed for that key is usually scanned in via a QR code, and you have it on your phone. And so that then becomes a second device that you'd have to have other than the user's password in order to get the TOTP. But it turns out that that's not the only place you can store a TOTP seed. You can also store it, for example, in Safari's very own password manager. So in Safari, I might have an account managed, the security credentials for an account managed at a website, where it stores my password and it also stores my TOTP seed. And if that's the case, and my Safari's password manager follows me around from device to device today, then that the access to that user's account is still protected by access to the Apple account, no different than it would be if they were just using an Apple passkey in the first place. So you really need to stop and think about, are you really getting high value assurances from a conditional MFA process that you might apply in addition to passkeys. And that's a non-trivial thought process. Before deciding, look, we'll let passkeys act as, say, a first factor of authentication, but we're still always going to apply conditional MFA as well. Best practices for those patterns are still evolving, and they're conversations that I'm definitely interested in having with folks who have an interest in this area and doing threat modeling for their particular line of business. Bottom line, though, is I definitely see so many benefits of using a passkey instead of a password that are absolutely, on platforms that support it, I'm going to recommend they be used to replace passwords. Okay, so a couple of demos now. I'm going to show the demo that Milan alluded to earlier, which is how we log in at work. And this is backed by our Verify SaaS platform. So we have a tenant of our Verify SaaS platform that IBM employees use to log in at work. And I've got a little video I'm going to play here where I'm going to go to one of our SaaS providers that we use for document storage, which is box.com. I'm going to get redirected to my corporate IDP. And at that corporate IDP, which is, in this case, it's going to be, the IDP for a SAML flow, we will do FIDO authentication. So let me play that video. You'll see I go to a box link. I get redirected to my IBM identity provider. It remembers that I use FIDO. I do Touch ID, select my account, and I'm logged in. And I know that's went very quickly and it's really fast, but that's the entire point. An authentication experience should be fast, streamlined, efficient, and then on top of that, you get all the benefits of it being phishing resistant and strong as well. So that was that. That's how we log in at work for the most part on platforms that support the platform authenticator. The second demo I want to show you today is actually this is a bit of a cat out of the bag demo. So as of tomorrow, we will be releasing IBM Security Verify Access 10.05. This is our on-premises offering that we've had from IBM for more than 20 years. So I've been working on this product for a very long time. And we're introducing in it a sample authentication policy, which is, we call it the Identify First authentication policy. There's many forms of Identify First authentication that you see on the web today, where the first screen you see is just enter a username. And then what happens next is based on either that username or characteristics of the account associated with that username. And so we've introduced this example policy, and it supports many different types of authentication flows, including, for example, redirect to a third-party identity provider if the username is an email address from, matches a specific regular expression or something like that. But the other things that we've done in this policy is we've introduced instrumentation for the very latest capabilities in WebAuthN from browsers that support them for passkey login. And that's what I'm going to show you in the demo today. So I will be logging in as a user called Jessica, and I'm on Safari here. Okay, I've sort of mastered what the browser is, but I'm on Safari here. And the user Jessica only has a password at the moment. Okay, so this is a typical consumer style account. Jessica only has a password. So I'll just start the video here. Jessica will log in, and what you'll see is when we hit continue, because Jessica only has a password, she'll be prompted to enter it, which she'll do. And then I'm going to pause it on the what happens next page here. So we'll let Jessica enter a password, and I've just paused the video there. And what we've done next in this particular authentication flow is if we detect that Jessica is using a operating system and browser that supports passkeys, and she didn't log in with a passkey, then we're going to do solicited inline registration of a passkey. So this is how do we onboard, Jessica into a passkey experience. And this look and feel is totally customizable and probably should have the new passkey logo on it. But the time we first put it together, the ink hadn't dried on that. So this is really just a screen which does solicited inline enrollment of a passkey. So Jessica's going to complete that. She'll go ahead and click yes. She'll be prompted to create a passkey, and she'll do that with Touch ID, or in this case, it's me acting as Jessica that did that, and the login flow is complete. Now, what we're going to show next is, okay, Jessica's logged in. Jessica's now going to log out, and then what happens the next time she visits the site and needs to log in? So let's see that in action. So Jessica visits the site again, and she's required to log in. Now, I'm going to pause the video right there as well. The first thing you'll notice is that the username screen has autofill capability, and it shows Jessica's passkey key available for use. And this is one of the new WebAuthN APIs that's made available. It's called the conditional UI or mediated UI. I think the friendly name for it is the autofill UI. And you instrument your login page to support that. And the website at this point actually has no visibility into the fact that Jessica has a passkey on the local device. So there's no discovery capability for relying parties here to find out if the current user has a passkey or not. The relying party site will not know until Jessica actually uses it. So Jessica is going to use it in this case and completes Touch ID just as they did for enrollment, and then they're logged in. And that is the new login experience for Jessica. Because it's an Apple passkey, you can see it's also available on my phone. So this is the exact same website. I just went to the phone and logged in as Jessica. Okay, so that experience is available in IBM Security Verify Access 10.05, which, as I said, comes out tomorrow. So we're just about at the end of today's webcast, but there's just a couple of takeaways I have for you. And that is that in IBM, we have been dealing with FIDO authentication and passkeys throughout this entire journey. For many years now, we've supported WebAuthN. We first certified in 2018 and delivered products to the market at the end of 2018 and early 2019. And besides the use cases that I showed you today, which were all browser-based use cases, we absolutely support native mobile apps as well. And our role in this whole ecosystem is to be technology that a relying party vendor might use with, and we also provide an SDK on the mobile platform for folks who want to use device-bound credentials only and not necessarily the platform's passkey implementation, which can be synced. So we have quite a bit of technology available on both the client and server side parts of this equation for folks who want to adopt phishing-resistant strong authentication. And we're in it for the long haul. So we're, as I said in my intro, I regularly participate in FIDO Alliance working groups, writing white papers and helping to evolve the standards. And in the W3C, I'm involved every second week at the moment in the WebAuthN working group, helping to evolve that standard and advocating for the needs of relying parties. So with that, I'm going to hand back to Millen. I thank you for your time and attention today. And if you do have any questions for us, there is a Q&A facility in your in the tooling, and we'll be happy to answer those for you.
Thanks, Shane. And I was just monitoring the chat. There's no questions, so I think you crystally explained FIDO and Passkeys. So thanks for that. So as a closing remark, you can get started with Passkeys and passwordless today with IBM Security Verify. We have a free trial out there. You go to www.ibm.com/verify. From there, you can spin up your free trial, and you'll be able to get the capabilities that we mentioned for a finite period of time. And if you need to extend it, reach out to myself and we can get that going. The other thing that I want to mention is there's a docs out there, docs.verify.ibm.com. That's basically our explanation, developer documentation, use cases, guides, best practices, set of documentation that gives you an understanding of how Verify can be used, what are the use cases we support, and even to the extent of what are some guides for best practices. So please take a look at both of these links. And thank you again for taking the time. This is a critical topic. It's something that is on the trajectory upward in a very rapid pace. So it's pretty important that organizations consider this. So there's actually questions coming in. So I'll read one of them. Other than Apple, can it be used with other platforms with biometric authentication?
Yeah, absolutely. So probably, so today, for example, if you're on Windows 10 or 11, you can set up Windows Hello for platform authenticator capabilities. Now, as of today, they are not synced to your Microsoft account and to your other devices. They're just going to be credentials that created and bound to the individual device, but they'll 100% work today, just in exactly the same way as the use case that I showed on screen. In fact, the use case that I showed where I was logging into my work account, I was actually using Chrome on my Mac, which also creates device-bound credentials and not synced passkeys today. The major part of today's topic was to really start getting you thinking about the security considerations of FIDO credentials that aren't necessarily device-bound, but all the technology from a relying party perspective works exactly the same, whether it's a device-bound credential or one synced. That's largely the decision that's made by the platform and the user operating the browser at the time. The relying party gets some signals about whether or not a credential is declaring itself to have been created multi-device or not, but the relying party cannot dictate that you will issue a device-bound or a multi-device credential. There's no controls in WebAuthN for that. So yeah, it will work today, and that's certainly useful to know.
Next question: can we enable face login too?
So in FIDO, the way a human performs user verification with their authenticator is totally decoupled from how the sign challenge is then sent to the server. User verification is simply declared as yes, we did it, or no, we didn't do it. So it's not like you as a relying party site enable face verification. That will come down to how the authenticator chooses and the user chooses to do user verification. So by way of example, right, if I'm on a Windows box and I have a fingerprint reader and a IR camera that can do face recognition, and I've configured those for use in Windows Hello along with, say, a Windows Hello pin, I can actually use any of those as my user verification method, and Windows Hello will tell the server, yep, user verification was performed. So you don't even necessarily know, in fact, you don't know what method of user verification it was, only that the operating system and browser are declaring that it was done. So that will come down to obviously the device's capabilities and how the user has configured their user verification methods between themselves and that device.
Thanks, Shane. Two more. And then this one, you can provide an answer, and then I can try to fill in as well. Can you provide feedback on lessons learned on implementing FIDO for IBM internal on-prem apps?
Yeah. So first of all, we only implemented FIDO at our corporate identity provider, and any other app that onboards does so via federation using SAML or OpenID Connect. So we have a single point where folks register strong authentication credentials like FIDO credentials. In terms of lessons learned, the number one thing, I guess, where we ran into challenges was making sure we only enabled the experience on operating system and browsers that actually supported an experience that we had tested, and that our help desk could help folks through if they ran into trouble. So we do use, and I still would encourage the use of intelligent pages that use some client-side JavaScripting capabilities to detect if FIDO is available and what sort of operating system you're running on, so that you can you can introduce it in a controlled fashion. For example, if you've got someone on Linux who only uses Firefox, they can't do certain types of passwordless flows today because Firefox on Linux didn't support them until, as it turns out, last night's Firefox nightly build. So if you're right at the bleeding edge of this stuff, this is hot off the press. The most recent Firefox nightly build added some CTAP2 support. But yeah, no, my number one lesson there is introduce it selectively. That's the most important lesson learned from our experience.
Yeah, and just to expand on that, I think one of the questions was around on-prem apps. So I guess just another consideration here, right? Just to sort of peel the onion back a little bit. So users in our use case are actually stored on-prem. So there's a pass-through authentication model that happens there, and there's componentry that we have with IBM Security Verify that enables that. It's called the pass-through for authentication bridge. So that's from a user standpoint. You asked about apps. There's also a component called the IBM Application Gateway that allows for proxying traffic from Verify to apps that may be behind the firewall. So those are two sets of componentry that can help in those types of use cases in terms of enabling and using IBM Security Verify.
That's very true. And that particular proxy basically takes OpenID Connect and exposes it in a way that federation works from our corporate IDP, and then you can use any one of a number of heritage SSO mechanisms from that proxy to your real app, whether it be HTTP header authentication or injected forms data. There's lots of different things we support. LTPA if you're on a WebSphere style environment. But typically what we see in most enterprise deployments today is that there will be an enterprise IDP, and apps won't ever manage individual authentication themselves. They'll delegate it out via federation.
Awesome. Okay, 2 more questions. We got 13, or actually no, 3 more questions. Got 13 minutes left, so we'll rapid fire these and continue. Please also keep continuing to ask questions. We're going to go through them. Next question, what was added to ISVA, IBM Security Verify Access 10.0.5 to support Passkeys that wasn't already there in ISVA's FIDO support?
Okay, so this sounds like it's coming from an ISVA customer that is looking for motivation to upgrade it. So there's a couple small things. Obviously, some of these capabilities are just exposed by using new JavaScript APIs in browser pages, and you could do that yourself, right? You could upload your own template files or author them yourself. But one of the things that we did that is inside of the product that you wouldn't have access to is we added attributes of a FIDO registration that expose the BE and BS bits in the authenticator data flags. So they stand for backup enabled and backup state. And what that would allow you to do is tell if a credential, when it is registered, has declared itself as backed up to a cloud or not. Right. So that's the very bleeding edge of that tech, and that's one of the things that is definitely only new in the most recent version of 10.0.5 that we added for Passkeys.
Awesome. And actually, the next question is actually one that I wanted to interject on, but I think it's a pretty critical thing to understand. So can IBM Security Verify Access or IBM Security Verify SaaS detect whether it's a device-bound or multi-device credential and platform different checks or different authentication flows based on that? And I think the other maybe question or thing to consider, Shane, here is, like, what's the delineation? I guess this is a second question. Delineation between the platform and the IDPs or the IDaaS or the IAM solutions in terms of how multi-device and single-device credentials are defined. So 2 questions.
Okay. So I'll start with the first one, which is, what can a relying party tell about a credential? First things first, you can't really tell anything unless you request that. You can't tell anything that is guaranteed to be correct unless you request attestation at the time a credential is registered. So attestation is an optional part of FIDO that allows you to request a proof of some type about the make and model of the authenticator and therefore infer its characteristics. Now, with traditional hardware security keys, they tend to do this quite well, and they'll give you a signed proof, and you use metadata documents that are published on FIDO's metadata service to verify that is indeed the particular make and model of a hardware security key, and I know I'm using a device-bound credential. What we've seen with the platform providers is for these multi-device credentials, and I'll say, like, Apple was the first to market, and their current implementation, it does not provide an attestation at all. Like, you just don't get one. So as a result, you can only treat the information that is provided as client asserted, right? It's not a proof of anything, but they do declare in that authenticator data those couple of bits that I was talking about earlier, the backup enabled and backup state bits. And if they're set, you can be pretty safely assured that it is a multi-device credential that's backed up to a cloud. There's not really much benefit to a authenticator that is single device setting those bits nefariously, right? They've got nothing to gain by doing that, because what really matters is what would you do as a result of, as a relying party, as a result of them being set or not set. And the idea behind reading them is actually so that if you see that a user has one or more multi-device credentials that's declared to be backed up to a cloud, you can offer to delete the password for that user. So that's the use case driving the presence of those bits. You might also want to use them in your risk engine to decide whether or not to do conditional multi-factor. But the real reason they're there is to drive the use case where you can say, oh, that user's got a backed up credential now. Would you like to delete your password? So that's what's available. If you've got attestation, you can find out a little bit more. But the passkey implementation from Apple and also the one that's in beta from Google on the Android platform today, neither of those provide attestation of the credential. So you just take the information you get as self-declared, right? And that's as much as you can find out. At least with today, the specifications have the provision in them for attestation to be included on any credential registration. But in the wild, what we're seeing at the moment is for these multi-device credentials, they're not including attestation information. The second part of your question, Millen, I might just get you to revisit that.
Yeah. So the second part is, and maybe it's just reinforcing, right, how multi-device versus single device gets enforced, who defines that, and what is the role and delineation between the platforms versus the IAM solutions.
Yeah. Well, I will say this, all right, as a relying party advocate, the relying party has very little control over whether a credential that's provisioned is single device or multi-device. Short of rejecting it after you've received the registration, which is just a horrible user experience, you really don't get any controls to say, hey, browser, I only want you to provision single device credentials. You just can't say that. The platform, the specification has no control for it, and the platform providers have made it pretty clear in the specification groups that they don't see that as a good thing to do, as much as some of the relying party vendors would like it. But so that said, my advice is, okay, we're going to get a mix of credentials that are single device and multi-device. Deal with it, right? Figure out a way that they're all okay, and perhaps you just tune your user experience a little bit based on what you can find out, rather than demanding it be of a particular type with particular properties. So if it's a multi-device credential, maybe I allow the user to delete their password. If I don't see a multi-device credential, well, I'll perhaps continue to keep my heritage authentication around for at least a second factor one, so that I've got some way of doing account recovery, right? Because that's the goal of multi-device credentials that are backed up to a cloud and can be restored on a new device, is that solves the account recovery process for end user accounts. And if I can't solve it by having a multi-device passkey, then I'm going to have to use an existing technique for doing that. And that may end up being the weakest link for, an attacker to do account takeover as well. So you have to make sure that could be an onerous experience, because you hope people don't have to do it very often, but it has to be one that, doesn't introduce the weakest link for account takeover.
Awesome. Thanks. There's a few questions on the application gateway. I don't want to answer them here, but if for the individual asking that, feel free to reach out to us on that specific topic, and we can dive a little bit deeper. I want to make sure we answer questions associated with the spirit of the webinar. Same thing with conditional MFA. We can take that one offline as well. The deck's going to be shared. The emails are on there, so feel free to reach out to us. Okay, so a few more. So for a case of an Android app, how is the integration? It depends entirely on the version of the device.
So there are device requirements if you're going to use multi-device credentials, i.e. the thing that's currently in beta from Android today. But Android has, for quite a while now, also supported non-discoverable. So these are second-factor credentials for FIDO on Android. That's been around for quite a while, and that's still a really good protection. And usable, and also usable from native mobile apps. So it's a great protection for phishing resistance, and also totally integratable with native mobile apps. So there's a couple of things that you gain out of being able to use a multi-device credential in the latest version of Android, albeit in beta at the moment. But there's also plenty of gains to be had if you're on an older version of Android, still supporting a device-bound credential for reauthentication, as opposed to, say, an experience where you do reauthentication via a login with a password and multi-factor. That's totally phishable. So yes, there are some things on Android that are version specific, and that is simply an artifact of the fact, a side effect of the fact that this is an emerging and still evolving technology.
Okay, 2 minutes left. Last question, and then we'll wrap it up. So for those that are still on, thanks for continuing to stay on. Okay, so is it possible to use with Angular clients where the login is controlled by the client?
Yeah, and yes, it is. So WebAuthN is a JavaScript API. In the forms that, or in the methods that you saw in the demos that I gave, those are all instrumented in JavaScript using the WebAuthN API, and with Angular you could certainly do that. So you might alter the user experience slightly in when and where you decide to invoke the WebAuthN APIs to suit that particular SPA style app, but 100% this authentication method is not restricted to any particular programming framework, or whether it will work with SPAs or not. One of the characteristics of FIDO authentication in general is that you get a freshly issued server-side challenge, and part of the FIDO flow is to sign that challenge with a private key managed by your authenticator. So one of the things you do in an SPA is make sure that when the user clicked, yeah, I'm ready to log in, there was some sort of background fetch request that went and got a fresh challenge, and then your navigator.credentials.get was called after that.
Okay, awesome. Not a question, but a comment, and we'll end on this. Someone said, thanks a lot for the presentation. So thanks again, Shane, for taking your time. I know it's a little late for you, but again, very important topic and a critical item for folks to get an understanding of the nuances. So with that, thanks everyone for joining, and stay tuned for the next one. Have a good day.